Hey, so today I'm going to give another talk on my EDA package for Horizon EDA. So just for reference, who hasn't heard of that project yet? Okay, so quite a few. So Horizon EDA is a full-featured EDA package, so it does everything from library management, schematic capture, board layout, 3D preview and export, and up to global export. So you can use it so it's just a basic EDA package. So you might be wondering why did that guy decide to write his own EDA package instead of contribute to something that's already existing. So some people say that a board can only be as good as the library of the parts, and so to me that's also true for EDA packages. So an EDA package can only be as good as the library data structure is, and I saw significant deficiencies in existing EDA packages in that regard. So that was one of my main reasons for starting a new one, since, for example, in KiCad, the part definition is basically the symbol, the pins itself, and it also contains the pad names. And for me, that shouldn't be all in one thing. And I also wanted to have a unified editor, so basically the same editor with all the same shortcuts and features for everything from symbol to board. And I also wanted to have a schematic editor that actually knows about nets, and just doesn't let you place labels all over the place. And to actually design boards, you need to properly specify your design rules, and that was also a key point for developing Horizon. And some implementation detail was that I didn't quite like about existing EDA packages, that they just happened to connect things if they had the same name or just hadn't land on the same location. And in Horizon, everything that is connected is actually linked in the data structure by ID. And I also wanted to play with new OpenGL3 features, and just wanted to have something I could play with and easily try out new things. So some details on implementation. It's written in C++ 14. It's around 70,000 lines of code right now. Just for reference, the included KiCad router that doesn't count to this number is about 20 lines of code. So I think it's quite small for what it does. It uses GTK3 for a UI toolkit, and builds and runs on any more or less up-to-date Linux distro and Windows. And people also reported that it builds and runs on BSDs. It uses JSON as a file format, and everything's linked by UUIDs. So let's get back to the first point. So what's wrong with libraries? So they're more or less like a file system that only has one level of hierarchy. So if you've got a library, and then inside the library you don't have like that much structure, and it's on the database that you can run SQL queries on. In Horizon, each item in the pool, so each package, each symbol, and so on, is in an individual JSON file, and the data of these files gets loaded into a SQLite database, and that database can then be easily queried for various properties. And the idea of the pool is that it only contains like actual parts you can order on DigiKey, so you won't find, for example, a generic any 555 timer in there, but you will find any 555 timer manufactured by ST in an SU8 package with the full part number in there. So how does the pool look like? So on the top you've got the part, so what are the rest of the things with names like entity and unit? So the part is like an actual part, but so a part is something that you can go to and then order any way you like, and you will get exactly the same one each time. But the part doesn't specify any of the things like the actual package. So it just references the package, but doesn't specify the actual footprint itself. Same with the pins. So the package is just your regular package with pins, pads, and other layers such as silkscreen and courtyard layers. And in Horizon, each pad is drawn by itself. So there aren't technically any built-in pads built into the code. They are all part of the pool. So weird pad shapes are there by default and don't require any ugly hacks. And these pad stacks can then get modified on the fly by, for example, by rules using a stack machine. So that one feature that the guy mentioned in the KiCad presentation, that's possible in Horizon since pad stacks get parameters from the package gets parameters from the board, and for example the things like the solder mask expansion or paste mask shrink come from the design rules, and other things are also doable with that method. So the logical definition of a part is grouped into unit and entities. So a unit is basically the prototype for a gate. So for example, in a quad AND gate, you'll have four gates that each reference the AND gate unit, and when one unit is references the power unit. And that's just a basically list of pins with their direction. And these pins also have alternate names, since these days you often have microcontrollers or FPGAs where a single pin has like 20 functions. Some people then just put like only PB0 in there, and you don't know if that's I2C or SPI. And in Horizon, each pin has one primary name. That would be PB0 in that case. And you can have as many secondary names as you like. So in the schematic, you'll be able to pick in the schematic which name will then appear. And of course, we have symbols. Symbols don't define the pins. They just read the pins from the unit and map them onto something that's actually visible. And because of that, you can also have one symbol for a unit. So you could have, for example, European or US symbols, or symbols of different width to accommodate the number of pin names you've selected. So that was basically more or less the same that was there last year. Now on to what has changed last year. So the biggest thing, in my opinion, was that Horizon has seen its first real-world usage. In that case, it's been my master thesis. So my master thesis was developing a board for an X-band transmitter. So basically the full signal flow from data generation in FPGA to a D2A converter to PLL for local oscillator generation, and finally the up converter. And my supervisors at the University of Stuttgart were kind enough to let me use my own EDA package, and I think that really helped, since it definitely raised my motivation for doing the actual board, and it also helped Horizon to be used for a real board, since that really got some features ironed out. So that's the board in 3D. Just to give you a brief overview, with the FPGA D2A converter and local oscillator generation in the PLL, and the mixer for final up conversion. And it's about it's 4 layers and has about 200 components, and also has some more advanced features such as differential pairs. So one feature that really helped to get this board done properly was the length tuning feature. So this D2A converter requires that the clock line is longer than any of the other lines, so the data gets sampled properly. And with Horizon, you can just measure the length of all tracks interactively. So you'll get this nice window that shows you the length of all the tracks you've selected before, and that window updates in real time. So you can drag these things down there, and they update, and then that window on the left will update in real time. So there's also the length tuning feature from the KiCad router. It works, but Personally, I don't like it that much, since I prefer to place the meanders by myself. So since you will need to order the parts for your board, Horizon also has a BOM export. Since we already have the part numbers from the pool, BOM export is a really natural fit. And right now the BOM export just exports plain CSV, but that's what everyone uses, and you don't have to use any kind of external scripts to reformat your bill of materials list. Just recently, Horizon gained parametric part search. So since the pool will in the future contain thousands of parts, and you will need to be able to search for these easily, each part can have parametric data attached. So like for example, for resistors, you will have value or tolerance, and these can be easily searched for in that interface that should look pretty familiar to everyone from various distributors. So since we have all the data, like description of parts or links to data sheets, we want to access that quite easily. That's why Horizon has got that head-up display. So everything that's under the mouse cursor and is selected will get info displayed in the top left corner. For example, when you over a symbol, it just displays the description of the part and a link to data sheet you can just click on, and you'll get right to the data sheet. And for example, for pads in the package editor, you will see the pads parameters like width and height. And if you select two of them, it'll show you the distance between those. So if you want to figure out the pitch, just select two of them, and you'll see it right there. Don't have to look into each each pad separately. So another feature that turned out to be really useful is copying of placement and tracks on boards. So even though modern ICs are more and more integrated and you need less of them, they happen to require many different power supplies. For example, on this board alone, all the blocks that are in red and even some more are just voltage regulators. These have the property that they are all basically the same, just different values, and you don't want to do the layout for each of them separately. So what you want to do is layout one, and then apply the tracks and placement you did for that one to all the other ones. So in Horizon, it's done like this. In the schematic, you select or you specify you specify groups and tags. So a group would be one voltage regulator, and you then so the yellow one, and the tag specifies the the more or less like local reference designator. So Horizon knows which component maps to which component in any other group. So that way you do your board layout for one, and just place the main component, for example, the switching regulator I see on the board, and just place all the other components somewhere. Then you select all of them, and tell it to copy the placement from the already routed section, and then you're there with just one tool. And when you've done that, you select the tracks on the left side and tell it to apply to the right side, and then you're there. And that process makes it really easy to do repetitive stuff like voltage regulators or other things that don't really need hierarchical design, and the hierarchical design is still yet to come, since there hasn't been any project yet that really required it. But there have been even more things. For example, you've got incremental search like in every modern text editor. Also some niceties like smooth zooming, or fully customizable keyboard shortcuts and colors, so you aren't stuck with my choices anymore. And also performance improvements like DRC that makes use of all available threads. But what's next from this point? So I've been working on Horizon for a bit more than 2 years from now, and it's been used in my master's thesis and some other projects, and some people told me, yeah, it's already really usable. And I think a release is appropriate, and so I don't have a really fixed time for that. But I think all the features that are features to use it for designing actual board are there. And so one of the things to do for that release are to improve the out of the box experience. So new users get gently introduced to the kind of complicated concept of the pool, and do user documentation in that regard. So here are some links to the project and to the reference design I did. And thanks to all the people on the internet that helped testing it and submitted bug reports and patches. And that's it for now. And now it's up for questions.
Plan to implement some way to import library symbols and packages from other EDAs?
Yes, I do. Since the plan was whether I have plans on doing import features for other application file formats. Yes. So importing packages for example, from KiCad would be a quite natural fit, since the definition of a package doesn't matter, so isn't all that different. And importing symbols is also doable, since the symbol contains everything that's needed to build a part in Horizon. So using a already existing package plus the KiCad symbol would result in a part, and that's definitely it's just work. It's not hard, but it just has to be done.
In the overview, you said that you only have like real parts.
Yeah.
But I often just specify 0603 1K.
Yeah.
And that's it. And then later on figure out which of the about 1,000 available ones I'm going to buy. Do you support that? So that you have like a generic part?
Yeah. Okay, so the question was whether there's a way to specify generic parts, since the pool should only contain orderable parts. So Octopart has that thing called the CPL, the Common Parts Library, and in there they have that naming scheme for like passives, like a CPL 1K or 603 0.1 watt, and I already imported these into the pool. And if you happen to use Octopart for your bomb generation, then Octopart will resolve these into an orderable part.
Other questions?
How do you handle parts that are just on the PCB, like a spark gap or a test point that is not orderable, but it's just or artwork?
Yeah. So the question was how parts just on the PCB are handled right now. Right now they aren't.
Okay.
So test points also so in my opinion you also have to appear in schematics. So you know where it should be logically, and things like spark gaps should in my opinion also appear in schematics. So these should also be included in the pool. But still, there's an option missing to make them not appear in the BOM output. The main reason for this is that no one has asked for it yet.
We have one here, and then you. We've seen a very nice plugin for KiCad in the last talk, and I'm wondering what's the support for plugins in Horizon?
Okay, so the question was whether there's support for plugins. Right now there isn't any, since that would require some of making some of the now internal APIs public, and since the project is quite in its infancy, that would restrict my ability to make easy changes. But so I don't have any plans to introduce a like Python plugin API for now. But yeah, if it becomes necessary in the future, then it might happen.
How stable is the file format? So are you already able to open like old projects?
Okay. So the question was on the stability of the file format. So the file format has always been backward compatible in that way that you can always open old designs, and the ability to read those designs will likely stay in Horizon for a very, very long time. But as soon as you save that file again, it might not be readable correctly by older versions. But there have been some small changes, but nothing that makes your design unusable.
You do more than 32 compilers.
So right now it's just a number. So right now I think there are like 4 internal layers defined, but upping that number to 32 would only require small changes. And I think I might be limited to what KiCad supports right now, since I use the KiCad's interactive router and have to map my layers to their layers. And if they don't support more layers than that, yeah, that's it.
So I was wondering, are you having any support for bus routing? So, so bus definition and or routing?
Okay, so the question was whether there's support for bus definition and bus routing. So bus definitions are supported. So they're actual buses, not just names in schematic. But bus routing isn't supported, since all of the routing stuff is pretty much just the KiCad router, and the KiCad router doesn't support bus routing yet. But if they happen to add it, I likely adapt it as well.
Just wanted to say that it's probably going to happen during the version 6 development cycle, but I don't want to make any hard promises.
So, more questions? I want the compatibility of the PCB rule tracking from its software. Some lines for high speed can be too close, but some line is not for high speed, just for power. The rule is some rules. How does this software suggest such thing like PCB joining line tracking?
Okay, so I guess the question was about design rules.
Yeah.
Okay, so Horizon supports something that is a bit designed like the rule stuff in Altium. So you can have many instances of the rules. Each rule has some criteria that it matches on. So for example, it can match either on net name or net class or regex that matches the net name. And so for clearance, you've got 2 matches. And if these 2 matches match, then that rule, for example, like distance, will get applied. And that distance rule can specify the distance between like track to track, track to wire, track to pad, track to board edge, or something like that.
Okay. I propose one more question and we move on.
If I want to use a part which is absolutely nowhere available, what's the workflow to create the footprints and everything?
Okay, so the question was what's to do with parts that aren't orderable. So the pools in Horizon support inheritance. So you can just create your own pool, define your personal stuff in there, and then tell that pool to include the global pool, and then you can just have parts for yourself.